All right, let's talk about AI. If you've ever been totally baffled or, let's be honest, kind of amused when a chatbot just confidently makes something up out of thin air, you are in exactly the right place. Today, we're going to pull back the curtain on one of the most important techniques in AI right now, Retrieval Augmented Generation, or as everyone calls it, RAG. Just think of it as giving your AI an external, fact-checked brain. Let's dive in. So here's the game plan. We're going to start with why AI models sometimes just, well, get it spectacularly wrong. Then, we'll introduce RAG as the hero of the story. We'll put it head-to-head with another popular method, fine-tuning, and then, the fun part. We'll walk through the basics of how you can build your own RAG system. And to wrap it all up, we'll tackle the big question. Is RAG really here to stay? Okay, so let's kick things off with the fundamental problem that RAG was even invented to solve. These large language models, or LLMs, are amazing, no doubt, but they've got some pretty serious blind spots. I mean, we've all been there, right? You ask a pretty simple question and you get back an answer that sounds super plausible, totally authoritative, but it's just completely wrong. And this isn't some rare glitch. It's a core challenge with how these models are built. You know, in the AI world, this has a very specific name: hallucination. A great way to think about it is like having this super enthusiastic new employee who refuses to read any news or updates, but will answer every single question you ask with 100% confidence. It's a total recipe for misinformation. So why does this even happen? Well, it really boils down to a few core limitations that are baked right into the models themselves. An LLM's knowledge is basically static. It's frozen in time, right at the moment its training data was gathered. It's kind of like trying to answer questions about today's stock market using an encyclopedia from 1995. It can't get real-time info, it never cites its sources, and when it runs into a topic it doesn't know, it just improvises. And trying to retrain these giant models every week, forget about it. It's unbelievably expensive and takes forever. So how in the world do we fix this? Well, that brings us right to our next section, RAG, the knowledge booster. If a normal LLM is like a student taking a test from memory, RAG is like giving that same student an open book exam with full access to the library. At its heart, RAG is a framework that hooks up a language model to the real world. So instead of only using its pre-trained static knowledge, the model first retrieves relevant, up-to-date info from a trusted source. And only then does it generate an answer. This whole process grounds the model in actual, verifiable facts. Okay, so how does this whole thing work under the hood? It's basically a four-step dance. First is indexing. You take all your documents, your data, and you turn them into these numerical representations called embeddings. You can just think of an embedding as a unique digital fingerprint for the meaning of a piece of text. This is what lets you search for ideas, not just keywords. Second, retrieval. When you ask a question, the system hunts through that index for the most relevant fingerprints. Third, augmentation. These little pieces of info it finds get tacked onto your original question, creating this super detailed new prompt. And finally, generation. The LLM gets this big augmented prompt and spits out an answer that's based on the fresh, factual context it was just handed. This diagram here just lays out the entire pipeline perfectly. You can see there are two really distinct parts. Up top, you've got the offline index process. That's all the prep work, where your documents get chopped up and stored. Then down below, that's the real-time query process. Your question comes in, the system retrieves the relevant stuff and passes it all to the LLM to create the final answer. It's a really smart way to separate storing knowledge from actually using it. Now, RAG isn't the only game in town when it comes to teaching an AI new tricks. The other main approach is something called fine-tuning. So let's put these two head-to-head and see how they stack up. Choosing between RAG and fine-tuning really comes down to what you're trying to do. Just look at the trade-offs here. RAG is king when it comes to keeping data fresh and secure, mainly because your sensitive info stays in its own separate database. And check out traceability. RAG can actually tell you where it got its information. Fine-tuning, on the other hand, it's more like teaching the model a new skill or a new personality, but you lose that direct link to the source data. So, the big takeaway here, use fine-tuning for style and use RAG for facts. Simple as that. Okay, that's enough theory. Let's get our hands dirty. In this section, we're going to walk through the high-level steps to build a super basic RAG system. And don't worry, it's actually way more straightforward than it sounds. First things first, you got to set up your workspace. Python is pretty much the go-to language for AI stuff. With one simple pip install command, you can download these incredibly powerful libraries like transformers from Hugging Face. And boom, you've got all the tools you need to get started. Next, you need your knowledge base. This could be anything, product manuals, research papers, you name it. Then you build the retriever component. Now, you could go all out and build a fancy vector database, but for a simple first project, a classic tool like the TF-IDF vectorizer is perfect. It's a really simple but surprisingly effective way to find documents based on keywords, and it gives you a great feel for how this whole retrieval thing actually works. And finally, we set up our generator. Using that Transformers library, we can get a text generation pipeline up and running with just one line of code. Then comes the real magic. You take the documents that your retriever found, you stitch them together with the user's original question, and you feed that whole big chunk of text into the generator. The model then gives you a response that is directly based on that context it just received. And that's it. That's the core loop. By combining a simple retriever with a generator, you've just built the fundamental engine of a RAG system. So now we know what RAG is, why it's so useful, and even the basic ideas behind building one. But is it really the final answer for AI? Let's zoom out and look at the bigger picture.
Yeah, here's the thing. RAG is not a magic bullet. This whole pipeline is way more fragile than it looks. As researchers have found, things can go wrong at any step of the way. Maybe a retriever just completely misses the right info or finds it but ranks it too low. But even if you find the absolute perfect piece of context, the language model itself can still mess up. It might fail to pull the answer out, or it could just decide to completely ignore your instructions. Every single step is a potential point of failure.
This all leads to a huge debate in the AI community, which I think a Reddit user just captured perfectly with this analogy. Is RAG this beautiful final solution we've been waiting for? Or is it a clever but ultimately clunky workaround, basically the AI equivalent of mailing DVDs that we're all just using until something way better comes along? It's a really fascinating question about where all of this is headed. And that really leaves us with this one final thought. Right now, today, RAG is one of the most practical and powerful tools we have for making our AIs more reliable, more factual, and just plain more useful. But is it just a bridge to some future where models can access knowledge in a totally different way? Or is this combination of retrieval and generation going to be a cornerstone of AI for years to come? Honestly, only time will tell. Thanks so much for tuning in.